Hello students, Secondary 1 Chemistry. Welcome you in the second term. This is the first period. Now I'm going to study Thermochemistry and Introduction. You know that everyone can do work. We say that this person has an energy. So the energy is the ability to do work. Energy has units as joule, kilojoule, and 1 kilojoule equal 1000 joule. There is also another unit for energy, calorie, and kilocalorie. 1 kilocalorie equal 1000 calorie. And the relation between calorie and joule is that 1 calorie equal 4.18 joule, which means that the calorie is a greater unit than joule. Here is a science called thermodynamics. Thermodynamics is a branch of science that deals with the study of energy and how it transfers. You know, in the preparatory stage, that there are many forms for energy: sound energy, light energy, heat energy, and so on. These are some types of energy. The unit of energy is joule or calorie, kilocalorie, and so on, as I said before. Here are some devices that changes energy from one form to another according to the law of conservation of energy. For example, the lamp can convert electrical energy into light energy, television from electrical energy into light and sound energy, and so on. Even the car can convert chemical energy from the fuel into heat by combustion of the fuel. Then the engine of the car converts her heat energy into kinetic energy. Here are some other devices that can change one form of the energy to another form. So the Thermochemistry, this branch of thermodynamics, concerned with the heat effects that accompany the chemical reactions and the physical changes. When you put two substances together and a chemical reaction occurs between them, this reaction is accompanied by heat change or energy change, which means that energy is entering in a chemical reaction, whether it is in a form of heat in the side of the reactants or in the side of the products. If the energy entered the chemical reaction in the side of reactants, we say that this reaction is endothermic reaction, and if energy is obtained in the side of the products, we say that this reaction is exothermic reaction. Here is a law of conservation of energy. You studied it before. Energy in any physical or chemical change can neither be created nor destroyed, but it is transformed from one form to another. If you want to know a new terms, here is a word called universe and surrounding and the system. Any part of the universe under testing or under experimentation, we say that this part is called a system. If you want to make an experiment here in this vessel, for example, we say that this vessel and its contents is called a system. Everything around this system is called the surrounding, and both of the system and the surrounding is called the universe. We should not say, of course, universe, but we say that the total, but the scientists said that the two parts, system and surrounding, are called universe. The system part of the universe in which physical or chemical change occurs, or it is the part of the substance chosen for study. Surrounding the part outside the system and exchange energy with the system in the form of heat or work. Here is the first law of thermodynamics, which states that the total energy of an isolated system is constant, which means that the total energy change of the universe is zero, which means that if any change occurs in the system, this change will be corresponding to another change in the surrounding, such that both of the two changes together are neglecting each other, and the result is zero. If this is, for example, the change in the system is plus 100, this means that the surrounding change is minus 100, such that the result is zero. So we can say mathematically that delta E for the system is equal to minus delta E for the surrounding, plus 100 minus 100, plus 5 minus 5, and so on. Here are three types of systems: open system, and closed system, and isolated system. This is an example for an open system. This open system, for example, a bottle without cover, and here is a substance inside this bottle. All this system is called open system because this system can exchange matter with the surrounding. This is the surrounding of the system. For example, water vapor can get out or enter, and heat can be exchanged in or out of the system. So this is called open system. Matter exchange and energy or heat exchange. Here is a second type, is called closed system, in which only heat exchange occurs but no matter exchange, because here is a cover which prevents getting out of matter or exchange of matter with the surrounding. Only heat change or energy exchange. Here is the third type of systems, which is called isolated system. The isolated system has a thick wall such that, and a cover such that no exchange for matter and also no exchange for energy, no heat exchange, no matter exchange. So this is called isolated system. The egg, for example, is considered an example of course, the egg is example of a closed system. What the contents of the egg cannot get out from the egg, but the egg can exchange heat with the surrounding. For example, when you boil eggs, here is an exchange for heat energy. So the answer is closed system. The human body represents an open system because the body system can exchange air, carbon dioxide, during breathing with the air, which is the surrounding of the human body, and also can exchange heat with the surrounding air. So the answer here is an open system. There is a difference between temperature and heat. Temperature is measured by thermometer, but here the heat it can be measured by the law, which is Q equal mc delta T, or by the calorimeter. Calorimeter is used to measure the heat of any chemical or physical change. The temperature is a measure of the average kinetic energy of the molecules of matter. When an object has high temperature, this means that the kinetic energy of the molecules is great, and vice versa. If the temperature of the object is low, which means that the kinetic energy of the molecules of this object moves slowly. Here the heat is a form of energy that can transfer between two bodies of different temperatures. The unit of Heat is calorie, joule, kilocalorie, kilojoule, and so on. The unit of temperature is degree Celsius or degree Kelvin. The temperature is a measurement of the kinetic energy of the molecules of matter. Heat is a form of energy. Calorie, what is the meaning of a calorie? The quantity of heat needed to raise the temperature of 1 gram of water by 1 degree. The joule is the quantity of heat needed to raise the temperature of 1 gram of water by about 1/4 Celsius. The specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree. The unit of specific heat is joule per gram degree Celsius. If you want to convert from kilocalorie to calorie, multiply by 500 by 1000. Here, 500 by 1000. Here is another conversion, but here from calorie to joule. We know that 1 joule equals 4.18, so if you want to convert from calorie to joule, multiply 900 here, right here, 900 by 4.14. A calorimeter is an isolated system that prevents the loss or gain of any matter or heat and used to measure the heat of reaction or the heat change. This is another definition for calorimeter. Here is a bomb calorimeter, an isolated system that prevents the loss or gain of any matter, as here, but here used to measure the heat of combustion. Combustion needs strong calorimeter called bomb calorimeter. Its wall is made of a metal, strong metal, but here the calorimeter wall is made of glass. This is a sample for calorimeter and its components here. The unit of specific heat here is joule per gram degrees. The combustion enthalpy of different substances is accurately measured by the bomb calorimeter. Here is a question: 4 substances. Which of these 4 substances has specific heat, high specific heat? Substance D, which may be water, because water is characterized by having high specific heat, which makes it used for cooling in the car. Any substance which has high specific heat, for example, here are many substances: aluminium, iron, copper, water, and so on, equal masses but different substances, and each substance has its own specific heat. Here are the specific heats of each substance. Water has the highest specific heat, so water, when it is heated, it is heated slowly. These metals are heated slowly, especially copper. Copper has the smallest specific heat, which means that this substance is heated very fast, while water is heated very slowly. If you want to calculate the quantity of heat absorbed by any substance which is heated and the mass of the substance is given, you can use this law. Calculate the released heat when cooling 350 grams of mercury from 77 degrees to 12. If you knew that the specific heat of mercury is 0.14 joule per gram degree. This is the needed quantity of heat. The M here is 350. Specific heat is this number. T2 minus T1. This is T1 and this is T2. This is T1. This is T2. So 12 minus 77. That's all. When providing a piece of lead whose mass is 15 grams by quantity of heat of 29 joule, its temperature increases from 22 Celsius to 32 Celsius. What is the specific heat? Here, the specific heat here is needed. The quantity of heat is given here to 29. This is 29. The mass is 15 gram. Specific heat is required. T2 minus T1. This is T2, 32. This is T1. So 32 minus 22. And solving this equation, and you divide quantity of heat over m by delta T. m to T2 minus T1 is called delta T. So divide quantity of heat over m by delta T, T2 minus T1. Thank you for listening.